problems are going to be really important to focus on, what topics are being. I won't be giving away tests, but yeah, that's all.
The joke didn't set in. So now let's start. So we're discussing graphing, what we are at. I'm still on section. Can everybody hear me? Is it in the back? Good or bad? Good. So we're still in section 14.1. Then I'm going to go back today to section 12.7. So they're a little out of order because 12.7 is more related to 14.2. Now, we start with the graph of we talked about functions of two variables. And we talked about domain and range last time. Here are the examples that we did last time. We talked about domain and range, and we talked about these examples. I'm going to bring back these examples today, and I want to graph these three examples. That's why I still have them over here. So last thing that I talked about was graph of a function. What is a graph of a function? The set of all values, x, y, graph of a function f from domain D, subset of R2 to R, is all the points x, y, z in what? In R3, such that z is equal to f of x and y. So take a point in R2, x and y, embed the R2 as a subset of R3. What is embedding? Meaning that you put the z equal to 0. That's when R2 becomes a subset of R3. Right down here. This is R2. XY plane is R2. XY plane, R2. Question? There we go. Okay, now it's fixed. So XY plane is R2. And what I'm saying is that for every point in R2, you find a z value using f. And so x, y, that z becomes a point in R3. Collect all those points together, it forms a surface. So this surface is the graph of f. Questions? Are we good with this? Okay. So let's do some examples. Do you guys remember I did this? That's this one, example 1. This one is example 2. Can you see it? And that one is example 3. Last time. Now, for those examples, I started it last time. Let's talk about it a little bit more. When I'm looking at that, it's all these sets, x, y, z, such that this is true. Graph is z equal to square root of x squared plus y squared minus 1. It's a surface. Do you guys know that? Do you know that surface? What is that? It's a hyperboloid of what? How many sheets? It's a one sheet because I can actually put in z equal to 0 and get something out of it. My question is, that doesn't look like that. What's wrong here? It's just a cut in half. See, if there was a plus and minus in here, it wouldn't be a function. If there was a plus and minus here, not a function. Right? But it's actually, if I make it z bigger than 0, which is this situation, this is a function. This is only plus. And it's just the upper half of it. So just the upper was. The lower waist is not. The upper waist is. It looks like a waist, right? It's just... Okay. That's the story. Now, I want you to notice this. This is a cool part. When I turn this around and I put, do you see which was the z-axis? The blue is the z-axis. I'm putting the blue into my nose. I'm looking from the above. Can you see this shape? Compare this shape to that. How do they compare? They're the same thing. If I'm looking from the above, the shadow of the graph on xy plane is your domain. Shadow of the graph on the xy plane is the domain. It could be the projection, not entirely shadow, because it could be under the xy plane, still make a shadow. Right? So from looking from the above is that story. Now, here we don't have a whole lot of stories. I just want to do the same thing that I did for the last one, because I did this last time, but it was very quick. Oh, look at this. Compared to that. Again, the domain you can see from the graph, directly from the graph. Put the z-axis where? To your nose. Point the z-axis to your nose. And here again. And I make it turn so x would be the horizontal. What does this remind you? That one. You can see the domain from there. Right? And the range is just slice it in z equal to constant direction. It tells you if you can slice in a z equal to constant direction, then you have that value as an output, that z value as an output. Questions so far? Turn it off. Did that blow your mind away? I think it's the coolest thing ever. I might be a little dork, but that's okay. So now, so that was fun. We looked at a bunch of graphs, right? But all we did so far is z equal to f of x and y, function of two variables. What if I have functions of more than two variables, right? So what if, let's say w equal to f of x and y and z, or xn plus 1 equal to f of x1, x2, all the way to x and xn. Right? How many inputs here? 3 inputs. So this is f from D subset of R3 to R. And this one is f from R, I should have called this G, R to power n to R, n inputs. In these cases, again, set of the set of all inputs is the domain, all possible. The set of all possible outputs is the range, right? The only little problem that appears, unless you're very, I don't know, clever, there are clever ways of graphing this. But remember, when I had function of two variables, where did the graph live? Was it R2? Domain was in R2. What dimension did the graph have? What dimension did the graph live in? 3. So if I have 3 inputs and an output, where does the graph of this one live? R4, right? 4 dimension. And this one in Rn plus 1, right? So the graphing becomes a problem. So what do? We introduce level curves and contour maps. And so the next thing that I'm going to talk about, I start level curve with that type of functions, then I end up with this type of function. Fair game? So we are going to use the level things. Questions so far? Are we doing okay? So, first of all, I want to give you a definition. Level curve of a function z equal to f of x and y is L sub k of f equal to all the points in the domain such that their z value is equal to k. This is a constant. So you may say like L2 of f. That is basically you're plugging in for z, you're plugging in k, z equal to 2. It's a cross section. This is a cross section in direction z equal to k. The only difference is with cross sections, you have them in 3D. With level curves, we typically put all the level curves in xy plane. With level curves, we keep them in xy plane. In the domain. It could be in higher dimension, the domain could be R2, or R3, R4, or so on and so forth. Now, oh, I didn't say contour map. So contour map, a contour map is a collection of several level curves. Level things or level curves. So you have them all together. Here's an example. Do you guys know what this is? So what do these lines tell you? It tells me, hold on. Do you see that? That tells you the height, that tells you the altitude. So is this higher or is that one higher? This one is higher. Okay. Let me get a bigger one. I have a big one, I'll pass it along. Okay. Say z value here is 4. Z value here is 6. Can you guys see this? 7, 8. Where do you think is the top of the mountain here? My watch or my other hand? Watch, right? So over here, where is the bottom of the valley? It's just decreasing over here, right? But then these two are of the same altitude and so on. Does anybody want to look at this? I can pass it along. No? So you guys kind of imagine I'm going up like this and I'm going up like this. Can you tell? Does my hand motion make sense? So it's you imagine from a 2D to a 3D. The next step, I'm going to give you an example in 2D entirely, solve it. But the biggest reason is then we want to talk about 3D. Again, sometimes this does a better job than drawing a surface in 2D. Do you guys want to do an old eye clicker? Are you getting bored? Let's do an old eye clicker, and then I do an example. If you want to pass it along, pass it along. Do this one. That's one that I missed. It's unrelated to this material, but I just have more to say, so I have to kind of stop you guys for a minute. What do you guys think? Which one is the answer? Michael, you're that way, I'm this way? So what is the direction? Oh, this is this one actually is related to your quiz right now, today or tomorrow. So which one is the direction vector? It tells you. Okay. So any vector in that direction or the opposite, exact opposite direction, you can scale it. Should be a direction vector. And you have a point. How do you write the equation of the line? This is which of these three sets of equations describe the line through points? Oh, I'm sorry. There is a typo in there. It's points, not points. Point. And there's a direction vector. Are we good? Everybody's good? Everyone? Can I stop this? So which one did you choose? Yeah. No. Yes. Okay, I'm counting down. 4, 3, 2, 1, 0. Oh, there's a big division. Let's throw this one away. Do you see another one of these? For those who did A, do you see another one of those? Yes or no? I'm running it back. I'm not grading that. Well, that was a little bad. Do it again. Four, 3. Is everybody doing this? 2, 1. What did you answer? Well, okay, I had 180. What happened? Come on, faster, faster, faster. Okay. 1/2, 0.25, 0. Somebody hasn't responded. You can contact me. I can look at your past responses. Come on. There we go. So one more. Since I started, I want to do one more. Do that one. This should be a quick one. How many options do you have? Not many, 2. Very quickly down to 2. Out of those 2, one is very obviously unacceptable. You can, so how do you do that? You say n times x minus, n dot x minus 1, y minus 2, and z minus 3. So basically,
is it the first thing?
so you have to have the normal vector. So it's 1 times x minus 1 plus 2 times z minus 3. What's the answer? Okay. Some of it I want you to answer very quickly. This is one of them. Are we ready? Yes? Countdown. 4, 3, 2, 1, 0. That's the answer. So, back to 1.4. Sometimes I have to keep you busy, otherwise, oh, thank you. So I'm going to do, again, contour maps, the level curves are interesting, especially for higher dimension. They're still useful because you already knew this. So it's useful, right? And you can tell which way the hill is, which way the valley is, right? So let's try to do a contour map for this one. It tells you the K. It's wanting you to find L0 of F, which is basically all the x and y, such that f of x and y is equal to 0, right? What is that? That's just this curve. Actually, that is not just one curve. What is that? X squared equal to y squared, x equal to plus minus y. There are 2 lines, right? So I'm going to draw that. One line, x equal to y. This is L0. X equal to negative y, or y equal to negative, again, L0. Now let's do one more level curve. L1 of f. What is L1? Set this equal to 1. Fair game? Everybody follows that much. So when I'm setting that equal to 1, what kind of a hyperbola is this? Opens this way or opens this way? It opens up. Are we sure? So if I set y equal to 0, I have x-intercepts. So it opens this way. I don't have y-intercept. I can't put x equal to 0, right? So if I set y equal to 0, I have x-intercepts. X-intercept 1 and -1. Everybody agrees? So it looks like that. These two are L1. Now, what about L2 of F? L -1. Sorry, L -1 of F. Then if I set, this is what you're solving, then I'm checking. This is what you're solving, I'm checking. Y equal to 0, is there an x-intercept? No x-intercept. Is there a y-intercept? Y-intercepts exist. And that's 1 and -1. L -1, L -1. It turns out that you can solve it. I don't need to do all of them. Then L2 is going to be this way. And L -2 is going to be this way. So can you guys tell me, if I'm going this way, what is happening? Z direction. Hill or valley? L1 then L2. Is Z increasing? Z is increasing because it's L1 then L2 as I'm going this way. It's like this coming up. That way going up, right? This direction, Z increasing. And also that direction. How about that direction? It's going down, right? It's Z goes to -1 then -2. So this way Z is decreasing and that way. That's why it makes a saddle point. Because on the x-axis, if you're getting away from origin, here's the x-axis, here's the origin. What happens to the height? Increases, right? Here's the y-axis. What happens to height? Decreases. So that's why the saddle point. It's saddle, one way goes down, the other way goes up. Right? The other way of explaining it. Fair game? You guys are okay still? Now fun part. Yes. And so the next part is, let's talk about the function of 3 variables. Let's say I have a function of 3 variables, f of x and y and z. Let me go to the page. Right? I have a function of 3 variables that is f of x and y and z equal to x squared plus y squared plus z squared. You guys tell me what is level 0 of f. Can you tell me? What am I supposed to set to equal to z, 0? The output. So I get x squared plus y squared plus z squared equal to 0. Do you guys know what this shape is? It's just a point, right? It's just a point. Point 0, 0, 0. Fair game? Now, ask me another level thing, level set. 4, L4 of f. What am I setting equal to 4? The output. So what do I get? I get a sphere. What is the radius of the sphere? Radius 2. What is the center? 0, 0, 0. can I set the, can I find L negative? No. But if I set bigger and bigger K, does the sphere get bigger or smaller? Bigger, right? That's the, and that's the picture. So what is R3 for F? Are these the graph of F? What are these 2F? I'm not going to go ahead until all of you answer. What are these 2F? That's a contour map. These are the level sets. R3 is the domain of F. R3 is the domain. Level sets. Okay. So tell me, this one says x squared plus y squared equal to 9. What is the W for the blue sphere? What is the output of the function for blue sphere? 9. Did everybody get that? Question. What is the output for the purple sphere? 1. Now let's see. Let's do one more fun one, and then maybe a few eye clickers. So here I have this function. It's asking me to find level curve equal to 1. So what would that be? It's x to the 4th over 4 plus y squared divided by 2 minus z squared equal to 1. What shape is that? That if I set z equal to 0, I get something. So this is hyperboloid of 1 sheet. I need more space. Then it said L0, so I said W equal to 0. What shape is that? Are we good with that? Cone. Then x to the 4th over 4, y squared divided by 2z squared equal to negative 1, because negative 1 goes in here, and that's a hyperboloid of 2 sheets. So the contour map looks like this, basically, for this function. Turns out we're not making this up. This actually is important in part of the physics. Maybe not the immediate physics you take, but higher up. It's actually an important function. And it tells you. So you guys do one. So what do contour maps tell me? The contour map tells me where the output of the function is what value in the domain. So it gives me points in the domain that with the value of the function, the output value of the function. Gives me height, gives me so contour maps tells you level sets, and each level set tells you the points in the domain that give you the constant value for the function. The output of function is constant. So you can think about it like, we're going to talk about it again, but we can think about that level set. Think about temperature. So temperature of the room, if you look at the surface, level surface, and the level surface tells you temperature of this level surface is so and so. But then this level surface is another one. Temperature function, right? We're good? All set? Ask if you, all set? Friends? All good? Oh, good, okay. I'm trying to also look at your faces and remember some of it. It's like an eventual thing, but you have to give me some time. Okay, so one, what are the level sets for, what does the level set for this shape look like? You set the z equal to constant. What shape are you expecting? Parabolas. 4, 3, 2, 1, 0. Oh. Okay, one more. Do this one fast. You have to decide, I think, for this one. You have to decide about what shape does it give you? Lines. What do I need to know about the lines? Slope. Hold on. So you're setting 4x minus 3y equal to a constant. Solve for y to find the slope. Right? Find the slope in there. Is it positive or negative? What's the slope? 4 over 3. What is the slope of each line? What is the slope of each line? Slope of each line? Positive. What's the number? 4/3. Okay. Counting down. 4, 3, 2, 2, faster. 2, 1.5, faster. And 0. Yes, positive. That's correct. Okay, you guys are ready? Every time I say ready, like a little spike goes through your spine, like a little buzz. Okay, oh, that's bad. What does she want? No? Okay. With this section, I'm starting 12.7. Are you guys ready for 12.7? You be ready? I have 12 minutes, Andrew. Okay. Do 10-second talk to your friend. I said do 10-second talk to your friend. He goes to ruffles all their friends' hair. Who's the ruffler of hair? Nick? You're Nick. Okay, I mean, your hair was different last time. I should know. Who ruffles hair? What, Nick? Okay, shall we? So I start with a quick review. I'm not going to write anything down because your hands get tired because I have a lot to write. Polar coordinates, cylindrical coordinates, spherical coordinates. Which one is the most familiar to you? Polar. You've seen it before, right? So let's start with the polar. So Cartesian coordinate, we have r, x, and y. With polar, we have r and theta. R presents the distance. What we have from before, we actually let the r to be negative if you want to. It just has different interpretation, right? In this course, I like my r to be positive. Unless otherwise stated, r is going to be positive in this course. Theta is the standard angle, standard position angle between the line that connects the point to origin. Theta is this angle. And that's the distance. Now, the question is, what if r is negative? If you have, let's say, if for r value positive, if I, for any r value, if I want to compare negative r and theta, basically that's going to be r and theta plus pi. So it goes to the other side. So if I have r and theta here, then negative r and theta is going to be here. If I have r and theta here, negative r and theta would be the other way around. And here, r and theta here gives you negative r and theta, opposite direction of each other. This part we don't use because we're going to assume r is positive most times in this course. Fair game? But you've seen this before. Now let's go. Let's remind ourselves a little bit. I think this is something that everybody forgets. How do I graph 1 and pi fourth? I draw a circle, radius 1. That would be my grid circle. Say grid circle. So you will have grid circles, right? There would be a lot of them. And then add on that one, I also draw theta equal to, so I find theta equal to pi fourth, and I draw a half line through that. That would be your grid radii. Grid radii. Not just radii, but the grid radius sort of thing. So from there, these two intersect, and that point is going to be 1 and pi fourth. So how do I do this one? I go the opposite direction of that, find that opposite direction of pi fourth, and intersection right there gives me negative 1 and pi fourth. How do I find 1 and 7 pi fourth? What is 7 pi fourth? Which coordinate is it going to be? Fourth, right? Because it's negative pi fourth. So it's going to be in here. So I draw the radii 7 pi fourth or negative pi fourth. This is negative pi fourth. And then that intersection gives me 1 and 7 pi fourth. And which is incidentally the same thing as 1 and negative pi fourth. We want to have only one period for theta. We want a continuous period in this course. So if I start from 0, I want to end up at 2 pi. I don't want to go round and round, that sort of things. We do that a lot in this course. Except when we say we don't do that way. Just like most times we do that way. I said, I forgot the most in there, I misspoke. But most times we want to do that. There are a few situations that I tell you it's otherwise. So again, what are the formulas? Let's do the conversion formulas just quickly. If I want to convert, if I want to find x from r and theta, what do I do? R cosine theta, r sine theta. Now, if I want to find, if I have x and y, how do I find r? Square root of x squared plus y squared. How about theta? I go tan of theta is equal to y over x. And then I solve. And I have to make sure that I'm on the right coordinates. Did we remember everything? Okay, can I start new one? Okay. Cylindrical coordinates. So let's start the cylindrical coordinates. Funky thing about cylindrical coordinates is that basically, put your fist in the air. Put your fist in the air. Then imagine the floor is XY plane. Drop a perpendicular from your fist. This is a point. Your fist is a point. Drop a perpendicular down on the floor. So that perpendicular is going to intersect the floor, right? XY plane. With cylindrical coordinates, we're going to take the z out of the point that is there, put the z down. Z doesn't change. What we do is, after we save the z, then we look at the point on the xy plane, the one that we drop down a perpendicular. So this is the shape. Here's your fist. You drop down the perpendicular, and that's the point of intersection of the perpendicular with the xy plane. Now they're making me laugh. It's unfair. So that's the drop a perpendicular. And this is going to be x and y and 0, right? Because it's in the xy plane. So z, it's the same x and y as your point, but z is going to be 0. Then from this point, connect x, y, and 0 to origin. This length is going to be r. Theta still is the angle that radius makes with x-axis. So x and y are going to follow exactly the same routine that polar coordinate followed. So tell me, what is the conversion in here? What is z conversion? Z stays the same. What about x? R cosine theta, y r sine theta. So all the conversions are like polar, except that z stays the same. X and y conversion and r and theta conversions are the same. Fair game? Are we ready for an example? I left the conversion formula page. Forgot to write on it. I have 2 minutes. Can I do an example? One example, I can't do any eye clicker on it. I do one example and I do the next one next time. So how do I convert this to cylindrical coordinates? What does this mean? R is equal to theta equal to z equal to 1. Now, what is x equal to? 2 cosine of negative pi fourth. What is cosine of negative pi fourth? It's in the fourth coordinate. What about y? Negative root 2 over 2. What about z? So I'm writing it as a point. What would that be? Do I have half a minute? Yes? So let's start the other way around. What does this say? X is negative 2, y equal to 2 square root of 3, z equal to 1. And then if I want to find r, how do I find r? And how do I find? No, you guys are ready to go. Bye, guys. See you later. Thank you for staying as long as you did. What is your name? Maroon. with an F or a V. Z.